Hi everyone, this is Amin, and in this video we're going to talk about how to have a monitoring station. We have a monitoring station, we have a remote area, we have our garage, the backyard, outdoors, something, even the kitchen. We need a sensor to sense the temperature, humidity, or whatever we want, even the motion, like the motion PIR motion detector. Then after that, it should send the data, like communicate and exchange them towards our center. So let's say we have a station, we have the center, this one gets the data and sends it easily to this one. It is the concept. How we can do that, this picture that you can see it here, it's an like simple example of that. Here I have one ESP8266. It is connected to this BME280 sensor. So this one is connected to that. Then both the development boards, ESP8266, both of the boards are connected to the Wi-Fi. So the one on the right, which is my station, what it does, it actually connects to the Mist AP that I have at home. It connects to the network, sends the data, gets that, then sends them to the network. The other one, which is my station, it receives and just print them out on an LCD. In this video, I'm going to show it to you how you can have this setup, and I'm going to upload the codes on the GitHub account. So you're going to download them, have the setup, and try it on your own. Just relax, sit back, and enjoy the show. To continue this video, we have a brand new ESP8266. There's nothing on that. As you can see, this part is empty. And we need we have the setup, so we need BME280. We come here to the tools, manage packages, and then here we just search name BME280. As we search it, we can see the related library, the MicroPython library. Click on it, then install. So it is installing. It doesn't take a lot of time actually. Yeah, there you go. So we have it. Then when we run it, we can see it checks the temperature of the room, pressure, and humidity based on what we said. It's an I2C one, we have sleep, then BME, we check the pins. If we take a look at the picture again, here we have what? We have this thing here. So the D1 and D2, which are the SDA and SCL, are connected to related pins, ground to the ground and V into 3. It is the important point that should be considered because BME280, it's voltage sensitive. So I mean, you cannot connect it to the other one, to the 5. It is connected to this one. And what my script does, it checks every 10 seconds. So I am in a forever loop. I check everything every 10 seconds, just print it out, and it works properly. It is the first idea. For the second part of this project or the video, what we're gonna do, first and foremost, we should bear that in mind, it's a real world project. In a real world, we're not gonna have the funny shell to check what's happening, IP address or something. We're gonna put it somewhere outdoor, and in this way, we need the onboard LED for our troubleshooting. I guess it's good to have a blink whenever you plug it. This is what I added to the script. Whenever I plug it, just a blink for me, and in this way, I'm gonna know, okay, my device, it is getting the power. So the power is okay, or the system is running. Then it should go through the process of getting IP address and getting connected to the Wi-Fi. Maybe it's good to leave the LED on forever whenever it is connected. In this way, I know, okay, I got the IP address. Then the other thing which is important to understand, which is more like a concept, in fact, we're gonna use the Wi-Fi router to be in the network. It's not like you send your data towards the Wi-Fi router and the Wi-Fi router will pass the data for you. No. We're gonna have a web server on our ESP. Let's go to the code. This is the code that you can see. I'm gonna import network, socket, time, and I2C pins. Here is the troubleshooting part that I said, connecting to the Wi-Fi, opening the socket, my web server, the HTML. After that, what we're gonna do, we're gonna have the code or whatever which are related to the sensor, and finally try to connect. And whenever you see everything is good, just leave the LED on forever. If I do it right now, just start it, let's run it and see what will happen. It is waiting for connection, trying to get connected. There you go, now we're connected. If I come here, what is the IP address? 76. 192.168.0.76. This is what we get. Temperature, pressure, I mean, whatever we had in the funny shell, now we have them here. The web server is ready. We're gonna save this one as main.py, unplug it, put it aside, station is ready, make the center the same concept, a code to, I'm gonna show it to you in the next part, but make the center and then we're good. Just a live demo, I'm gonna record everything when I'm connecting them and the LEDs, and then we're good. To have the center, what we need simple script like that, only like for the lines. Import the network, time socket, and here is for the LCD to monitor. This is our LCD, it's I2C. Then we should get an IP address, so connection to the internet, printing out. In this case, I mean, in the previous one, we didn't have any LCD, so the LED was showing us if you're connected. In this one, since we have the LCD, I use the print option on the LCD. Whenever I'm connected, I see that my IP address on the screen. The other thing is that when we have a GET request, since it's a web server, we are going to get a raw HTML data. In Python or in other programming languages, there is something really cool with the name of regex. So you can use regex to extract what you want. Here in MicroPython, one of the drawbacks or bugs or whatever you can call it is that there is no regex. And since we are getting the specific raw HTML, what we're gonna do, we use the index function. It's part of strings. We convert the raw HTML to a string and use the index so we can find the number of in temperature, number of the strings in temperature, add some numbers to that, like okay, temperature, TEMPR something, maybe 13. Whatever the index of temperature is, add 13 to that, then you're gonna get the number. So in this way, we will have our information. If you come a little down, you'll see this is what I did. I used index and then I added some numbers to that and printing them on the screen. Let's see how it goes in the live demo. This one is on the right hand side. It's the station side. It is my development board, ESP8266, and the BME280 sensor of the temperature, pressure, and humidity connected to each other. This one is voltage sensitive, not more than 3 volt for that. I'm gonna connect this. So based on the behavior that you're expecting, as soon as we plug it, there is a very fast blink. It means it is plugged. I added another one inside the script, first line, so it means okay, the script is running, which is a good sign, and whenever it gets the IP address, it will be on constantly forever. And I set a static IP address on that. Okay, the first blink, second, and there you go. It has the static IP address because we don't want it dynamic every time it changes whenever there is a voltage outage or something. On this side, we are asking to check this IP address that we already know what it is. I'm gonna connect it. Since we have LCD here, I added some more cool stuff that like initialization while it is trying to connect to the internet. Then it gets the IP address. Actually, it happened really fast. Then it goes to that. Room temperature is 20, and humidity is 49%, which is kind of high, I guess. And so let me, every 10 seconds, it tries to check the situation. I'm just rubbing my hand, probably, yeah. I wanted to say humidity will change first. If I keep on doing that, I'm sure temperature will be changed. So every 10 seconds, yeah, you can see. There you go. A couple of things that are valuable to be mentioned at the end of this video. I've learned something while I was capturing this video. And what is the thing? There are many limitations in the matter of microcontrollers. So we should not consider this small piece of development board as a computer. There are many limitations, like in the RAM, in the processing speed, and everything. And since we are working with MicroPython, not C, I would say it exacerbates the limitations and the situation. So what we're gonna do in this case, first of all, at the beginning I had a script, and what my script does, it gets the information from the sensor and put all of them in a HTML code, so you can open it with your browser. It gives you pressure, humidity, and temperature. And every 10 seconds, based on the tag that I added in the HTML code, every 10 seconds we have the refresh of the page. Then on the center side, I was getting information from that. I realized it is a mistake. First of all, what do we have in our LCD? Just pressure, just temperature and humidity. So pressure is extra. We do not need that. What should we do? We should remove it. The first thing. So we're gonna remove 2 or 3 lines, extra lines that are unnecessary. Also, the idea for this project is to have your sensor, put it into your backyard, into a shed, into a garage, somewhere like that. In this case, what will happen? You're not gonna plug your laptop, or I don't know, you're not gonna check it with your web browser. So there is no need to have a tag for every 10-second refreshing. What is the point here? You are removing some lines. At the same time, you're getting a raw HTTP GET request. In your GET request, you're going to get all of these informations. And on the center, it should check everything. You are removing some processings from both sides. And at the same time, these refreshing, and when we have a socket, we should open a socket, we should close the socket. And that refresh, which goes in the middle, when you want to have your get HTTP request, it causes some sort of communication problems, and the center cannot get the information from the sensor or your station. It is the idea. For that reason, I'm gonna add 2 files, 2 MicroPython files on my GitHub account. First is the one that you just want to monitor on your computer. The other one is the brief one, or the better understanding, I would say microcontroller readable, for the main idea of the project, for having a sensor or station and a center. I hope you enjoyed. I hope you find it useful. And if there's any question, doubt, unclarity, uncertainty, just put the comment below. Have a good day. Take care. Don't forget to subscribe my channel. Bye everyone. Bye.